I started the recording.
Okay, cool.
And I'll pick up my ranting about other stuff, which was keeping my attention away from this meeting. But I didn't do my homework.
I mean, me either. So we'll do our homework right now together, I guess.
All right.
So one thing that I was thinking would probably be a good idea for a recording is maybe you just want to say why you're interested in understanding this MakeMint contract a little better. I think that'll give people some context.
Well, we are looking to create community currencies.
Yeah.
And the short-term goal is just to figure out how we call the MakeMint contract to create a new currency.
Yeah.
And then how we do transfers.
Yeah.
With that. Okay. The longer term, I guess, objective is to actually understand sealer unsealer type things and how we can do I guess the ideas behind the multi-sig contract and how we can create contracts that we control by consent or consensus or multi-signatures, whatever. So the simple part is maybe just creating a currency, right? Maybe.
Yeah. Well, yeah, probably. I don't know exactly. I'm a little less familiar with the multi-sig stuff, but I think it's more or less this. I mean, the idea that you just said, basically, just having, specific public keys or contract names that have access to the contents of whatever it is that you're storing there. So like the template, I guess, is some sort of vault or purse, and that's where you have a multi-sig wallet or something along those lines. It's probably the wrong name for it. I know Mike was making a distinction between vaults and wallets, and if I remember correctly, he said the distinction was that a wallet has some capacity to do signing, or maybe it contains your keys in some sense, and a vault does not do that.
Yeah, I think a wallet is associated with some public key, generally.
Yeah.
Whereas a vault doesn't. And I guess there's some distinction between a vault and a purse. I don't know.
Yeah. So, I guess first maybe we can just look at vaults and say a little bit about those. So let me just remember where a good place to start is. So one thing that I do want to mention is when I was working on these contracts, I went through the painstaking effort of making comments on almost literally every single line. So hopefully, even if you don't have a whole lot of background with this stuff, you can look at this contract and get some insight as to what in the world it's trying to do. No promises, of course, but that was my intention with writing these, very detailed comments.
Okay. Are you making a pull request of this back to the?
It should be there already.
Yeah. Good.
Yeah. This before this morning, I rebased on the current dev, and I haven't been working on this specific branch. I mean, I open branches for specific things if I want to do changes, but this is what should be on GitHub currently.
Sweet.
Yeah, and so the only thing that I really wanted to say was that these vaults are stored in this vault map store, or really I guess in the vault map. But either way, what the vaults do. I mean, basically a vault contains a purse. So it's like a purse with some sort of capability, right? Like you can only access the contents of this vault if, you have some certain piece of information. I don't totally remember how all of that stuff relates, but I think in our create vault, yeah, so here's like, we're creating some vault here. This is an even better one, this vault. These, all these methods are a bit confusing. Yeah, but basically, I mean, your vault contains a couple things. So, like when people say vault, really, they're just talking about some sort of unforgeable name that corresponds to a particular contract. And that's one of these, RevVault guys from this contract. But basically, I mean, it has an address associated with it, and it also has this purse associated with it. And the purse, so maybe if we just go here, okay, it's right there. The purse is basically just like some process that holds a balance. So it doesn't know anything about like who's allowed to have the, who has the rights to like have this, access this balance. And so like basically all you can do with a purse is say like, okay, purse, like tell me how much you have. And then you, of course, you can transfer, rev or tokens or whatever from one purse to another. And you kind of invoke that on a vault. But basically, I mean, the whole point is, right, like, and if you had the purse already, we wouldn't need to do this auth key check, and we would just be able to like say, say I had access to like a purse that you owned, and I would essentially just be able to take your tokens, right? But if I only know something about your RevVault, well, that doesn't give me your auth key to then authenticate transfers out of the purse that contains your rev. That's my understanding of it, or at least what I remember of my understanding of it. So that's more or less it. And then, what I should say is this purse thing is just an unforgeable name that corresponds to this non-negative number contract. So this is what a purse is, basically. This non-negative number thing, right? Because if you look in like RevVault, when we do, let's see, where did we? Oh yeah, this is new vault, blah blah blah, blah blah blah. There's got to be some sort of, okay, hold on. There's going to be, dang it, maybe no, there's probably in it. Just trying to remember where this stuff happens. Yeah, so we did this per split. Okay, maybe I should look at this. Yeah, maybe let's see if we got split elsewhere in here. 4 matches, that sounds good. But there's all of them. Okay, per split. Nope. Maybe it's in here. Okay, make purse. Or there's got to be a split method in here. Yeah, one match. Here it is. All right, so maybe I misspoke about the non-negative about the non-negative number stuff. Okay, so now what it looks like is anytime we mint some token, so that's like a call to this MakeMint contract. Anytime we mint a token, what we're going to do is, create this name, this mint, which is the name of some contract. This mint contract has this method called MakePurse. So once we have, once we have this new token, which we got through calling the MakeMint contract, we have the ability to make purses that hold that specific kind of token. That's kind of what line 24 here is saying.
So we can just say make mint, and then we take the new mint, and we can make a purse with any arbitrary number of tokens in it.
So yeah, I mean, basically, so what we're going to do is, provide some return channel, essentially, right? We call MakeMint on some channel, some name. And then what it's going to do for us is create three unforgeable names, also this Decker function. And what these names correspond to is, so this guy corresponds to some contract that gives us the ability to make purses. And so, okay, so what I said before wasn't totally wrong. It was just like not convoluted enough, because what the make purse thing does is just calls this non-negative number contract and does this initialize thing on it. And basically all that is you're supplying some kind of name, this in it, and then some kind of return channel. And then, but the point is, like, we do a call to this non-negative number contract, which basically initializes, right here, just initializes some instance of this non-negative number contract, but with your, special name that you're referring to this contract by, sort of. So what happens there is, so not only do we do that, so we've like initialized some instance of the non-negative number contract. We, put this thing on this balance channel, and then basically we're going to use, what does non-negative number return on the channel? I honestly don't remember. So what it returns on this channel is, well, let's see. So it returns, okay, like a bundled name, essentially. So everything is very convoluted. But what's happening here is when we do that call, so let me go back. When we do this call to non-negative number, right? So, okay, like where did non-negative number come from? It came from the registry, right? So at the very beginning, we're doing this call to the registry to get the non-negative number contract. We take it as a process for whatever strange reason. It doesn't really matter. I mean, it comes back as a tuple. We take it as a process. I mean, obviously you can change that. But here is where we have the name for the non-negative number contract we got from the registry. And then once we have that name, we can go ahead and make calls to the non-negative number contract. And basically what we're doing is we're saying, like, okay, I'm providing you, it's a process, but, basically we'll think about it as a name. I'm providing you with this name and some particular channel. And what the non-negative number contract does is it says, okay, I'm going to take your name and I'm going to take your channel. And what I'll do for you is produce a few names. This name has several methods defined on it, because basically it's the name corresponding to a couple contracts, right? I mean, so I don't know if you consider this to be like one contract and then this to be another contract. But for me, it's kind of like we have some sort of object and now we have some methods on it. And so this has 3 methods on it. right? Like we can either do this add thing, which will do some checking of a balance, and then we'll say like, okay, we can add some rev to it, or maybe we can't add some rev to it if like there's a potential for overflow. Because we're using, I don't remember if it's 60, I think it's 64-bit integers, but either way, it doesn't really matter. And we can also do this subtraction thing. And I mean, basically, what's the point of like the add and sub methods? It's so that you can do something like put rev into a particular purse, because remember, this is basically a purse. And so like we can call this add method on a purse, and then what that allows us to do is just like put more rev into a purse. But we'll also need to do something like subtracting rev from a purse, and then this value thing is basically just to read the value that's in that particular purse. And and you can notice like once you have this name, you can call these methods at will. Right, so we have to do some sort of protection of that name. Otherwise, like once you know that name, you can just add or subtract whatever you want from somebody's purse. And so the important thing is the way that this thing's returned, right? It gets returned on this channel. So basically, what is returned is right here on 52, and it's this write only bundle with that name. Okay, so going back to this MakeMint stuff, right? We do this. So we have this contract, this mint, which is basically like how we work with the particular tokens that we just minted. And basically all, I mean, what I remember my understanding to be is that all a mint is of course, it's like these two contracts, but kind of the most important part is this name, Decker. And basically what Decker does is gives you the authority to take some tokens out of a particular purse.
Do you have any idea what Decker is short for?
I assumed decrease because that's what it's giving you the authority to do. So I'm trying to think of a good entry point to talk about that a little more. Yeah, because I mean, we can just start going through this internal make purse thing. So the internal make purse contract. So that's the second name that we got here. The first name was basically just to give us the ability to make purses, right? But when we make a purse, we got some non-negative number, something returned from non-negative number contract call, which was some write-only bundle that held a name in it, whatever that name was, that non-negative number made this. And we also, so then we grab, we grab that thing. So this is like some, write-only bundle. And then we do this internal make purse call, which is basically going to say, okay, I'm going to make a purse. And then, well, we can just go through it because here's the make purse contract, internal make purse contract. And so, trying to remember why we need this stuff. Okay. Yeah, so, okay, let's see. I mean, we can just start walking through it and I'll try to figure out what's going on as we do that. So we're taking whatever we got returned from the non-negative number contract, also supplying this return channel because ultimately we'll return something. That's, the typical pattern for these contracts. We first of all create two names. I mean, this log store name just has something to do with giving you the ability to log some activity on a particular purse. So like you can track, you know, if where's an example of it being used? So you can track, you know, like how much was decreased from the purse at what particular block number, blah blah blah. So that's you know, something that this name gives you the authority to do now, or like gives you the ability to do, I guess maybe is the right way to say it. And what this purse does is, I mean, you know, here's a contract with this purse basically. And so I forget what they called this thing. Well, I guess really just technically that, yeah, I guess this thing, right? So I know like this decker is a name. Basically we made the name here by, you know, so all of this junk is just like some really verbose syntax for doing something like a let binding, like this. And basically what we're saying here is, you know, this let binding is basically just saying like this whole crazy thing is that, right? So I'm just going to refer to like this, well, okay, and like to be very particular, right? This is a name. So the whole thing goes in, you know, some curly braces like that. But the whole point is like, this decker is a name. It corresponds to this crazy like bundle with a bundle inside of it, and that internal bundle has the name of this contract, and it also has the name of this decrease function that we created up here. And then the whole thing is, we read that name like exactly as is. That's what I remember the syntax being. I don't really remember what it, oh, it was a reference or something. I forget what the name of that syntax was, the equal star thing. Basically, we have a name and we don't want to like shadow that name. We want to like take it exactly as is. But either way, what are we doing? So
what's the branch that this is on?
This is on the dev branch. Yeah, dev branch. So it should be in Casper, source, main, resources, and MakeMint.
Now, how do you get? I don't see a dev branch.
Don't see a dev. That is really? When you go to RChain, what branch is it on? Because for me, that's the one that shows up automatically.
Well, it shows up now. But,
okay, yeah, I don't know, man. That for me, that's always been the one that's shown up automatically. But yeah, but then you're in Casper, source, main, resources, and then there's all of your there's all of the contracts that are needed for Casper, basically. So you know, your proof of stake, like auth key stuff, multi-sig stuff, just some like operations, MakeMint. That's the one we're looking at. That's what's in here. They're on.
Okay, I found
37.
Yeah, I found the dev branch now on the other one.
Okay,
When
yeah.
you search, it seems to give you some random branch.
Man, I have no idea. Like I said, it's every time I've gone on here, it's always just you know, do RChain dash RChain, and this is where it brings me. So I didn't even know that it would pull up a different branch. I mean, there are tons of them, so like you could be looking at a lot of different stuff.
Yeah, no, I just did a search for the routines. MakeMint.rho.
Oh man, yeah, that's because GitHub's search feature is horrible.
Yeah, and yeah,
My
so
experience is terrible.
the branches are alphabetical, but the dev branch, because the default, is first. I
Yeah.
didn't find it alphabetically.
Oh yeah, yeah. Okay, that makes sense.
All right.
Okay, so that's where that is.
So, Steve, are you following? You have questions?
No, this is good. Just getting exposed to, all this kind of the flow of the logic and familiarity with the new channels and names and everything that's being created. So the more I hear it, the another piece element I'll make sense. But this is good.
Yeah, like I said, I tried my best to put all of these comments. I mean, if you ever download it and look at who did the comments, like 95% of the comments were from me.
You're the best.
Thanks.
Yeah, we appreciate that.
I don't think anyone who is doing development cares, but I felt like this was more of a community service. Like if anybody is to look at this crap and understand it, there's no possible way you're going to do that without comments, because that's how I felt. It's like I'm pretty familiar with the ideas already, but I look at this contract and it's like, wow, like what in the world are we even trying to accomplish here? And in my opinion, like it doesn't take that long, especially if you understand all of this logic, to just write a couple comments. Like, I don't know, whatever. That's my opinion. That's how I roll, at least. So I mean, if you're like looking back at this stuff later on and you're like, man, I do not remember what in the world was supposed to be happening, like why did we do this, like that sort of stuff. So there are comments. I tried to do at least a decent job of explaining what was going on, and also like where things were coming from, right? Because for example, we just do this call here, like, okay, balance subs, like where did this come from? Like where does this method live? Well, it lives in the non-negative contract, non-negative number contract. So I tried to when we refer to methods existing in a different contract other than the one that we're in, because of course this is MakeMint, I liked to just say like, hey, you're calling something in the non-negative number contract. Just to make it a little more clear, decrease the amount of guesswork. But okay, so yeah, I wanted to show you where this decrease function was actually used. I guess it's used here. So remember, we did like all of this crazy binding to this name, and then basically picked that name up right here when we called this first contract. And we called this first contract with some amounts, and of course there's always a return channel just so I can get an error message or whatever, success message if everything works out. And basically what we're doing is we're saying where's a good place to start? So I'm saying, okay, I have some decrease function, basically, right? Like I have some name that represents my authority to decrease from a purse with like a particular token in it, a particular kind of token, because it's associated with the mint, right? It's associated with the call that was made to the MakeMint contract. And basically what we're going to do is, first of all, this check here that starts on 46 is essentially just saying like, okay, we have some purse and we want to make sure that we were provided with the correct decrease function. And so by that, what I mean is, we have this purse, okay. We're going to basically take the decrease function that's associated with the instance of the mint, the MakeMint contract we're in, right? That's this guy. And what we're going to do is basically look at the decrease function that's associated with the purse that we have, which we're calling this purse. And then, okay, we grab those values, great. And then what we do is we basically say like, hey, okay, so I returned the decrease name for this purse. That's the output of this guy basically. I returned it on this name, and the output for this for whatever reason I called it Decker bundle. And so we pick up both of those things and we just say like, are you equal to you? So like, does this purse that I currently have my hands on, does it have the right mint basically? Like, is this, whatever, if it's whatever your community token is that you created, you're just checking to make sure that like, this is the right token, that like, we're talking about the same token. Otherwise it would be really strange to start subtracting, tokens of say like type A, when you have a purse with tokens of type B, and it's not even really clear, like there has to be some sort of conversion rate there. Maybe that's a feature that will be ultimately added in, but it's not even clear what that means right now to extract tokens that are actually a different mint from a purse that holds tokens of some mint. But okay, so then basically the point is like we do that check, right, to make sure that we're dealing with the right type of token. So that's what the check on 51 does. If we have the right token, then okay, great. We can go ahead and do our like check this purse and see if it has enough tokens so that I can actually do this subtraction, because this is basically like I want to transfer some amount of tokens, and this is basically the amount of tokens that I'd like to transfer out of. I think it's out of this purse. It's a little bit confusing as to like which one it's coming from and which one it's going to. And again, I tried to make notes on that stuff, and I probably did, and I'm not even reading them.
So is the reason that it saves it in the channel just to do like a let? Because it's obvious. It seems to me it could use the bungle 0 star Decker.
Yeah.
Without having to store the Decker.
So you're talking about this one?
I'm talking about on line 46. Yeah.
46. Yeah.
Okay.
So yeah. So here, what we're doing is we're taking this name that we have, that represents our authority to subtract some amount from a purse, which basically just checks what mint it is. And we're saying we have some purse, and we don't know if these represent the same mint. And so what we need to do is just check that this purse that we have access to currently does have that right mint.
What I'm asking is why do we bother to store it? if
Why
we
do we
just
bother?
created this name, Decker Channel, now we store
Yeah,
the value
yeah.
into it, okay, why do we store it and then read it back again when we could just use the,
Oh, yeah, because I wrote this, and when I wrote this, I was an idiot, and I didn't realize that I could just, instead of doing that, I didn't realize that I could just, well, so, okay, so what I wanted to do was write this, bundle 0 of the Decker channel, right? And when I tried to do this, it wouldn't compile because it said you can't do = bundle 0. And I was like, oh crap, I need to do something better. And then after doing some playing around, I noticed that, well, if I store it at some name, then I can just compare this thing with this name and everything is good. And then Mike informed me that all I really needed to do was that. I mean, so like all this is doing is, you know, effectively doing this comparison, right? So there's kind of no reason to have that at all. There's no reason to have this. And really, that's all I wanted to do in the first place.
all right,
Okay, right.
that makes that makes sense. Thank you.
When I wrote it, I was ignorant. That's why it stores that thing.
Okay, but
Yeah.
this contract is much older than, I mean, how long ago did you write this?
So I put this on, you know, January 27th, apparently.
Okay, so this is new
this part is new, because what wasn't being done before I introduced this is there was no check to make sure that the mints of the purses were correct.
Right.
Right. So there was still the ability to like mistakenly subtract tokens of type A from a purse that holds tokens of type B. You know, and like this is really useful when you have your different shards, which is essentially what you're saying, right? Is like you want to create some sort of token. I mean, and that's, you know, essentially like a shard. Like, what is a shard? It's basically you're keeping track of some certain mint. I mean, you know, and I'm sure there's more to it than that, but that's kind of like a fundamental part of it.
Right. Well, we want to, you know, we're going to be creating a community token. So we'll be having purses that will hold community tokens, right?
Right. Yeah, and so what this,
that would be nice if we could
what doing this if else thing will you know, not allow or however you want to say it. It'll basically say like Rev and the community token are not interchangeable, right? Like you can't just like, well, you know, Rev that is you know, an instance of the current mint. So there's kind of like one Rev, right? Like Rev is whatever the currently minted tokens are, and any tokens can be minted. But you don't want to be able to say like, you know, oh, I'm not even sure how to say it exactly. You don't want to be subtracting from a purse that holds Rev what you think are community tokens, basically, is the way that I understand it. Right. And like I said, of course, at some point in time, there has to be some kind of contract or some functionality that holds some kind of like mapping that is like a conversion rate in the different tokens. So you could do some sort of you know, like you want to exchange, and I guess it's basically an exchange, right? You want to exchange some community tokens for Rev, and there's some established notion of like what that conversion rate is, and you know, you can just like call whatever contract it is that holds that information. So Yeah, so you know, a lot of well, there are a lot of methods that are being defined here in MakeMint. This one, the place that you do something like this is when you want to do a transfer. And so let's see. It's always so difficult to find what I'm looking for here. So we want to do a transfer, and this may not be exactly the right place, but we want to do a transfer from some vault to some rev address. Sorry, we want to transfer from vault at that rev address to this rev vault. Okay, so it looks like this guy is the vault that the tokens are going to, and this rev address, you know, is the address associated with some vault, you know, that also has this auth key associated with it that wants to like transfer rev to this rev vault. That's what that comment is supposed to mean.
From.
And, yeah, what's up?
Isn't that from the vault? To the vault, anybody should be able to send it, no?
Yeah, so yeah, we're sending from the vault that's associated with this rev address to this rev vault. So like the name, you know, that we have as rev vault here. Yeah, so I mean, and again, like you know, rev vault is just some unforgeable name, right? Like when you create a rev vault, you have some unforgeable name that's generated, and basically like that unforgeable name, which we're referring to as rev vault, right? Like that's the human readable form of the name. That thing, you know, it has like a bunch of methods defined on it, basically, right? And like one of them is a transfer method, and so this is like a transfer method into this rev vault that you just created from some other rev vault. And we, you know, of course, we'll do some checking to make sure, like, you know, this auth key provided is the right auth key for the rev vault at this rev address, and all this nonsense, and all of that junk lies in this transfer template business, which is, you know, down here and just like utter horrendous. But you know, that's what it is. And so I mean, you know, what I was just saying is kind of like the first thing. Okay, it's like horrible to try and keep track of all this stuff, like rev address and, you know, purse and blah blah blah, whatever. So basically, you know, like we have our rev address we want to transfer to this particular vault. And what we're going to do is provide our rev address. I don't remember what that thing is. It must have been defined up here. Oh yeah, sure. Because when we created this vault, this is the name that it has. That's why we're defining these methods on it. This is the rev address that this rev vault is associated with. Right, so like, okay, a rev vault is kind of three things. The three things that it is some unforgeable name that you refer to it in terms of like that's the name of the contract that you call when you want to perform operations on this rev vault. It has some rev address associated with it. That's what I'm calling this. And then it has some purse associated with it, and that purse is the thing that we can like add or subtract, you know, tokens of a certain mint from. And so what's going on here? You know, to do a transfer, right? We call this transfer template. So basically, the first argument to the transfer template is the rev address of the vault that we're transferring tokens to. Maybe I should have called this to rev address, but it doesn't matter. This purse is the purse of this, you know, the rev vault that has that rev address. This rev address is the one that is trying to take tokens out of it and put them here. This is the amount of tokens that we're trying to do that with. this is the auth key that's associated with the RevVault at this address. That's what we provide here. And then this is just some return channel, for lack of a better name, Rev2. And so if we go down here to this horrible thing, this thing is awful for several reasons. Not the least of which being you have to call multiple different contracts to execute all of these validation steps, because like the either is another contract, right? It's this guy, it's horrible. The auth key is another contract. This one's not so bad. Like it fits in my screen, and my text is even big right now. But that's what we got going on there. And either is basically just like operations. It's like some kind of thing that's reminiscent of an either type for rholang, basically.
I got a couple questions.
Yeah, sure.
And we've got about 8 minutes before Casper stand-up starts. So when you can, with the make contract, say I want to create 1 million tokens, so you can specify how many tokens that you specifically want to make, correct? So so I make I can put in there I want to make 1 million tokens, or I can make 10 million tokens. This contract allows me to make a specific number.
So not this one, but this one.
Or the MakeMint. Okay.
Yeah. So I'm just trying to remember where that actually happens. I think non-negative init. What does init do?
That's what it sounded like. It was the init was.
Yes, that's the balance that you initialize with. Yeah.
Okay, so we specify the balance number of tokens that we want to create. Now, when we create a token, does each token have some like unique identifiers for each of those tokens, or is there any uniqueness for each token, or not necessarily?
Oh, that's a really good question. That I don't know. I don't think so,
because I think they're non-fungible. So if they're fungible, that means each token is unique and has a unique quality for each of them. So and I think that's what the ERC 1155 does, those types of things. So I get a sense that that's not the case. So that's good.
Yeah, because I mean, like where are the tokens actually created? I mean, they're created here when we call the non-negative number contract, right? Because we just say like create.
Right. Okay. Yeah. Okay. So that answers that question. And
that you can add or subtract from, and that's your purse basically, and it's got 100 tokens in it.
Right. So we create it, it goes in the purse, and then as we want, we can decrease it and move everything to like a treasury address or something like that. And
so if we make
identify the tokens, but I feel like that's something that could be added on,
Okay.
So if we make community tokens, okay, they're not Rev. So the RevVault contract is going to be wrong. I mean, we're going to have to make another version of it. We're not dealing with Rev.
No. The RevVault contract, it doesn't care specifically what your tokens are.
So we're passing it the mint something.
Yeah, this is another good question. Yeah, you're right, because you pass in the mint contract. That's fine. So basically, Yeah, so I mean, you do a call to the MakeMint contract here, and basically it's like for any mint that you have, like I can do all of this stuff essentially, right? Like you can get a vault with that particular mint.
So if we run this, we're actually going to get something. We'll get a complete copy of the Rev capability,
Let me think about
which
it.
actually is misnamed because it wouldn't be a Rev Vault. It would be a
Right. I guess we could take this file and rename it to, Collab Coin or something like that.
We don't have to rename it. We call it and it'll give us a community currency.
Okay. Right.
Yeah, so actually now that I'm looking at it, I think this is the right connection. Like if you were,
I think, Isaac, you're cutting in and out a little bit. I think you might be having some mic issues.
it produces this mint name basically, which is what you use as the new mint and for this token.
Okay.
Right. So like if you have a different instance of the RevVault contract, like it automatically produces a different minted token.
All right.
All right. I actually need to get going here. I hope that was helpful though.
Yeah, and one last question.
Sure.
There's right now with the sharding, there's no backing contracts to connect. So if we create a collab coin, there's no backing contract that connects that child shard to the parent shard to the collab.
Right, exactly. And so yeah, that's kind of what I was saying a little bit earlier was there's no way to like convert or exchange between the two different tokens. So like you can think about it as two different shards, but they're like totally disconnected from one another.
Right.
So to have some sort of bridge between those shards, you would need validators on either shard that are keeping track of like the traffic or the activity on the other shard, and then have some sort of agreement of like, okay, something about tokens on like the other shard, and so both ways, right? Like agreement from validators on both of the shards.
And that
we'll have this separately first on the main shard.
Yeah.
And then if we have it also, if we have an equivalency with this on another shard, then we'd have to program that. And it's time for the
Casper stand up.
Casper stand up.
Yeah.
Good to see you guys. Thank you.
Yeah,
All
thank
right,
you, everybody. Have a great day.
Yeah, cool. See you later, guys.